Good afternoon, morning, whenever you're watching this. It's Miss Jonesy here. I am back for week 4 of distance learning. It's been 4 weeks, guys. It's been a while since seeing you guys. I miss you all. I hope you're still staying safe. All right, let's jump into it. Objective. Today, I will continue the new unit of forces and magnetism by making observations of a photograph and reading pages 4 through 8 in The Attractive Truth About Magnetism in order to gather evidence and information that will support me when answering the following 2 questions about the text. Question number 1. How does magnetic force flow through a magnetic field? Question number 2. Will one south magnetic pole and another south magnetic pole ever be attracted to one another? Those are 2 questions that we will be answering today by 1, looking at this photograph and making observations that the objective says, and secondly, reading these pages 4 through 8 in this book, The Attractive Truth About Magnetism. All right, so we started magnetism, I think maybe the week that we actually had to leave to quarantine. So this might be refreshing to you, but it also might be, you might have forgotten in the weeks that we've been gone. So no problem. We will be starting fresh today to get through it. So agenda, number 1, quick review of our principal's letter. I need you guys to, I don't know if you've seen this already. I saw that Ms. Haynes sent this out on Remind, but this is something that's very important for us to note. Okay, the principal sent out a letter that kind of has some frequently asked questions that maybe you or your parents are wondering. And there's one point that I really wanted you guys to pay attention to, which are these 3 frequently asked questions. One says, where do I go to find the videos and online work packets for my child? All that information is on our Stanton Pride website, as well as myself and Ms. Haynes have been texting all the numbers for you and your parents to get all the information. If you're signed up with Remind, we've been sending it through Remind, the videos. We've been reminding you every day to do the videos, to turn in the work, as well as it's on the school website. Now that we're in week 4, there really is no explanation or excuse as to why you haven't even turned in work or why you haven't heard from one of the teachers / reached out to the school to figure out how to get to your work. So it is week 4. We got to get on it. The second question is it true that the work students are doing online will not count towards my child's grade? That's false. Okay, that is false. For term 4, it says it right here. This is from our principal. For term 4, April 27th through May 29th, your child must participate in distance learning with their teacher twice a week to receive a passing grade. Students who do not participate will receive an NM, not met grade. So it's actually important that we hear from each student and family. I have several kids who have either turned in math and they haven't turned in reading, or they've turned in reading and they haven't turned in math. Okay. And then I have some who just haven't turned in any work at all. So you see it right here. You will be receiving an NM if you don't turn in any work. It's actually not okay for you to be home for over 4 weeks and not have checked in with your teachers, not have turned in any work or figured out how to get to work. So you see it right here from our principal. If you have any questions, the third one says my number may have changed or may not have heard from anyone. Who can I call to connect? Here are the phone numbers of the school as well as the principal and the APs. Now, you also have our phone numbers, myself and Ms. Haynes's. So several ways to contact us. You can go up to the school to speak with the front office. There's no reason as to why you shouldn't be able to get this done. So that's the first thing I wanted to show you guys, just so you guys know, you got to make sure that you're doing your work. Secondly, all right, this video is going to just require paper and pencil, nothing too deep, nothing too serious, and an open mind, ready to listen and learn. But I want you guys to take a second and actually pause the video and grab these materials that you need, at least 3 sheets of paper and a pencil. So pause me, grab the stuff you need, and return to me. I'll be here waiting for you. Cool. All right. I hope that you guys paused me and you grabbed your pieces of paper and your pencil and you're back now. Third thing on our agenda is an observation or question using the gallery photo. I said a lot since we read the objectives, so just to remind you, remember we're trying to figure out these 2 focus questions. How does magnetic forces flow through a magnetic field? Okay, and will one south magnetic pole and another south magnetic pole be ever attracted to one another? Okay, those words might sound confusing. You might be like, what are you talking about? Right? But you're gonna, by the end of this lesson, not only understand these words, but also be able to answer these questions with evidence from the text. All right. So observation and question using this first gallery photo. Okay, so this is the first thing I want you guys to do. I want you to take a look at this photo right here. Just observe. Think about all the things that you see that's happening in this photo. All the things that look familiar, all the things that don't look familiar. What do you see is happening? I want you to think about all the things that are happening in this video and make a great observation. Right? As you're thinking about that, I'm going to pull up the questions that will be applied to this as well, which is this. You should have gotten a good chance to look at that picture. If not, rewind a little bit and pause it, but then also come back to this part in the video. Okay, and these are the 3 questions that you are going to be answering, or 4 questions really, that you're going to be answering on your first white sheet of paper. Okay, so you can pause this video and actually look at these questions. I'm going to read these questions to you out loud, and then you can pause it. But this is the first part of your work this week, is simply your observations from that picture. Okay, so the first question says, describe what you see in the picture above. That's your first question. Just describe what you saw in that picture above. Okay, I already started to restate it for you. I said, according to the picture I see, and you fill in the rest. What do you see? What did you observe? Okay, that's the first question that should be written down on your paper with your answer. The second question is this: based on what you see in the picture, what do you think is happening? So the first picture just says, what do you see? Okay, I want you to think about what you're looking at, what you're viewing, what you're observing. A lot of good readers, when they're reading and there's pictures or there's graphs or all the text pictures that go along with text, they do a good job of just observing what's in there. And then they make inferences. What do you think is happening? Okay, that's why the sentence starters that I gave you is, I can infer that what's happening is, and you fill in the rest. Super easy. Helping you. I'm restating the question for you. Okay, the third question is, why do you think the pencil and the rubber band are still on the floor? Why do you think that the pencil and the rubber band are still on the floor? Restated that question. I can infer that the pencil and the rubber band are still on the floor because you fill in the rest. Tell me why. Why do you infer that? Why do you think that the pencil didn't get, or whatever's happening, and the rubber band are still on the floor? And lastly, the last question is, what do you know about magnets? What do you know about magnets? What do you know about electricity? How do you use them in your everyday lives? Okay, I started the first question. There's 3 questions within this one question. It says, how do you know about magnets? What do you know about electricity? And how do you use them in your everyday lives? Okay, I know a lot about magnets. For example, tell me what you know about magnets. The way that I skipped one. I know blank about electricity. Okay, what do you know about electricity? I know blah, 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 blah about electricity. Fill that in. And then the third question says, how do you use them in their everyday life? The way that I use them in my everyday life is by, and you fill in how you use these magnets and electricity every day. Okay, so those are 4 questions that should be on your first sheet of paper with your answers clearly stated so that I can see what you have written. This is a very, very easy first exit ticket that I would like to see you guys text me pictures of or email, whatever the case is, but this is your first stop in the lesson. All right. All right, let's jump back to the lesson. Now, it says let's go over some vocabulary and background visual video. Okay, so let's go over some vocabulary. Some of you were probably like, magnetic force, field, magnetic pole. What is she talking about? There's so many big words. Miss Jones, help me. Don't fear. I'm here to help you. All right. So let's go over some vocabulary so that hopefully some of this isn't so challenging when you're working. All right. So the first word is magnetism. Okay. We're going across. We're talking about the word, then we're talking about the definition, the picture, a synonym for the word. We can get specific with the word and then use the word in a sentence. These last three boxes on the last couple words are not filled in. It was meant for you to fill in, but we're not going to do that, which just to save time. We're just going to go through the words, the definition, and if I can think about a sentence on the spot. All right, so magnetism, that's the word. The definition of magnetism is the power of a magnet to attract and a force that pushes and pulls certain metals. Okay, so those are the two definitions for magnetism. So it's the power of a magnet to attract, and it's also a force that pushes and pulls certain metals. Okay, this is a picture of a magnet or magnetism because you have the magnet and you have some nails, and you can see something's being attracted, something's pulling them together. A synonym or a word that means something similar is attraction, right? You're attracted to the magnet and the nail. There's enough attraction, they will pull together. And then let's get specific. When I feel my refrigerator magnet get pulled to the refrigerator door. Okay, have you ever had those magnets that maybe you got from, I don't know, amusement park or something, and you want to put it on the refrigerator, and before you even can like put it on, it's like something's pulling it towards it. It's gravitating. It's trying to get on there itself. Okay, that's magnetism. And then using it in a sentence. Magnets use a force called magnetism. Okay, that is the first word. Now, some of you were like, force? What is a force? Magnets use a force. The next word is force. Word is force. Definition: the use of such power, energy, and strength. Okay, you use force. When you use force, it's using some type of power, energy, or strength. Okay, this is a picture. I see somebody trying to pull up something from off the ground, or they're pushing it and pulling it, right? So it's like using the energy or your strength to push something or to pull something. Okay, that's force. Or even like think about tug of war, right? If you play tug of war with your friends at recess, right, and you're using force to pull the string, or you're using force to push something away. Okay. Now the next word is attract. The word is attract. The definition is to pull something towards something else. So force and attract are similar in a way, right? Because you are forcing something, meaning you're pulling it, right? Or you're pushing it, right? But attracting means to pull. Now, the opposite of that is repel, which is to push away. So when you're both using force in both of these words, right? But it's either attracting, pulling it towards you, or something else, or repelling, you're pushing it away. Okay? So those are the 4 vocabulary words that you need to know. Magnetism. Okay, it's the definition is the power of a magnet to attract a force that either pushes and pulls certain metals. Okay, and then you have force, which is the actual use of the energy, like the energy that's around whatever you're pushing or pulling. And attract and repel. Attracting is pulling something towards, and repelling is, I don't like it. Push away. All right, so those are the vocabulary words for the text. Now, let's look at this quick video. This video also will give us a little information about the magnetic force and the magnetic field. She has an accent, so just you can hear her pretty clearly, but I'll talk a little bit if there are words that I feel like you might need some help with. All right, listen.
You must have seen a magnet with this shape before. It's called a bar magnet. It looks like a chocolate bar. What happens if we bring it near an iron nail? We know that as we bring it closer to the nail, at some point the nail moves towards the magnet and sticks to it. Moreover, it remains there until we manually separate it from the magnet. So why does an iron nail stick to the magnet? This is because of the force of attraction that binds the magnet and the nail together. This force is applied by the magnet on the nail and hence it's called a magnetic force. Here is one interesting question that I want you to answer. Is magnetic force a contact force? In other words, is the contact between a magnet and the nail necessary for the magnet to attract the nail? Let's look at the animation in slow motion. We are moving the magnet towards the nail. And at this point, the nail also begins to move towards the magnet. It means the force came into action even when there was no contact between the magnet and the nail.
So contact meaning something touching, right? So if her question was, does the magnet and the nail have to have contact in order for there to be a force? And you're about to find the answer.
Hence, we can say that a magnetic force is not a contact force.
It's not.
Contact is not necessary for the magnetic force to work on the nail.
Why is that? Ask yourself, why is magnetic force not a contact force? Why is she saying that when the nail was here and the magnet was here, that it didn't have to actually touch each other before it became intertwined? Okay, why is that?
To understand this better, we bring this magnet close to the nail and move it slightly up in the air. You will find a slight movement in the iron nail as well. This means that the iron nail is under the influence of a magnetic force even though it's not in contact with the magnet. It again proves that a magnetic force is not a contact force. So we can say that it's a non-contact force. The force exists even though the magnet is not in contact with the iron. But what does this non-contact nature of the magnetic force tell us? It tells us that there is an invisible field produced by the magnet in the space around it. And if you bring any ferromagnetic material in this field, then it experiences that force of attraction. We cannot see this field, but it exists.
Interesting point. Invisible. We can't see so many things that are happening around us, right? There's like an invisible forces all around us that we don't even realize. For example, like earlier when I was talking about if you've ever gotten a magnet from, let's say, an amusement park and you went to put it on the refrigerator. What is the thing that's drawing that magnet to the refrigerator without us forcing it? It's not like we're like, boom, and then it falls down. There's something that keeps it held together, and there's something that's dragging it closer. It wants to get together. There's something invisible that we can't see. Like, I wonder if we had some, I don't know, goggles that we could like see other forces and actually be able to see all the things and all the forces that possibly exist around us.
This field is produced by a magnet and hence it's called a magnetic field. Now I'll ask you an interesting question. Do you think the strength of this field is even throughout the area around the magnet? Let me explain this to you with a relatable example. Assume that there is a working Wi-Fi router present at some location. It gives off signals in all the directions in some range. Now, in order to connect a mobile phone to the internet, we need to bring it in this range only. This signal will be stronger nearer the router. The closer you bring your cell phone to the router, the stronger the signal will be. One can think of magnets in the same way. A magnet has a magnetic field around it. The strength of this field is greater closer to the magnet and decreases as we go farther away from it. As you bring any ferromagnetic object in this field, it experiences a magnetic force. The closer we bring that object to the magnet, the greater the force it will experience until at some point where the force will be large enough to make the object leap towards the magnet.
All right, so I love the example that they gave in here because it's so true. How many of you have been on your cell phones and you're like, oh, I don't have any service, or I can't get on Instagram or whatever it is? It's probably because you're not close enough to the magnetic field that the Wi-Fi is giving off. Wherever you are, whether it's in school or at home or in a store, and you're wondering what's happening, why your service is not strong enough, a lot of chances could be that you're not close enough to the router that actually is giving off these forces to get you access to Wi-Fi. So the closer you are to the field, the magnetic field, the stronger the force will be. The further you are away, the weaker it will be. Sorry, I don't know if you can see underneath here. It says weak force underneath where it says my screen is being shared. Okay, so those are some good ways for us to understand a little bit more about the text that we will read today. All right, so we are well into our agenda. All right, let's move on to number 5, close read of the text, right? So we're still thinking about this question. How does magnetic force flow through magnetic fields? How does this force flow through all the magnetic fields that exist? And secondly, will one south magnetic pole and another south magnetic pole be attracted to one another? So I know the second question might be a little confusing, but as you saw in this video that the lady that we just watched, there was different poles of a magnet. You see on here, it says south and it says north. Let's click on it so you can see it better. Come on. You don't want to get larger? Fine. All right. But you see how it says south and it says north? Okay. There's different parts of a magnet that we will learn today. And the question that they're asking us is, that I'm asking you, that we're figuring out together, is simply, will one south magnet pole and another south magnet pole ever be attracted to one another? Field. Now she wants to.
Now I'll ask you an interesting question.
We don't want to hear your question anymore, ma'am. All right. So those are the two questions. How does this force flow through the fields? And then if I had one south pole and another south pole, will they be attracted to one another? Let's figure out those answers. All right. We'll figure out those answers reading The Attractive Truth About Magnetism. Let's start. All right. Title. Now, before we start this text, I want you guys to know that this text is written in a sense that's kind of like a graphic novel, one that kind of has like humor to it. So sometimes you're gonna read the captions, and it might sound like somebody's talking to you, or they're saying a joke or something, because there's different forms of text that authors that they write, and this is like kind of like a graphic novel to get people more interested in whatever they're writing. All right, so title. The caption says, just following the rules, my teacher said I need to put a title at the top so readers know where to start. You have the power to push or pull objects without touching them. Your superpower even works through walls or water. All you need is courage and a really strong magnet. Okay, so you don't really have a superpower, but you do have super cool magnets that can do these things. Magnets use a force called magnetism. I remember from the question in my vocabulary, there's the first vocabulary word, magnetism, some type of force. I remember Miss Jones saying that was a definition and reading that. This invisible force allows magnets to attract or repel objects just like a superhero. 2 more of the vocabulary words, attract and repel. So this invisible force either pulls something towards, because I know that's what attract means, or pushes something away, because I know that's what repel means, certain objects. Interesting. Just like a superhero. Magnets are all around. They're in your TV and computer. You probably have one on the refrigerator to hold up your latest art project. Here goes another caption. Or maybe it's holding up that test that you didn't study for. Yikes! Hopefully not. Once again, you see at the bottom of this page in the text, it says the definition for attract, which is to pull something towards something else, and repel, which is to push apart. This is very interesting to note this. I want you guys to know, as readers and as authors, sometimes authors will put the definition for some words that they're wanting us to know the definition for to make our reading better at the bottom of a text. So when you see a word that's bolded, like attract or repel, go, 9 out of 10 chances are that it's at the bottom of the page, or it's in something called a glossary at the end of a text that has the definition for you. Don't just skip over the bolded word and just keep reading. Most of the time, authors are telling you the definition because maybe the average reader just doesn't know, right? Or it is very important for you to know in whatever the author is writing. So make sure that every time you see a bolded word like this, okay, you always go look for the definition, figure out what the definition is, and then read the text knowing the definition. Let's keep reading. I command you, paper, to stay on the fridge so all can admire my amazing artistic talent. This superpower thing has gone too far. So you can see this is a mom and a daughter or a son. I guess a daughter, whatever she is, holding up her superpowers to make sure that her magnetic force is holding up the picture. I don't know if that necessarily is going to work, but it's a cartoon. Magnetism is a power people use every day. Without it, TVs and cell phones wouldn't work. Even cars wouldn't go. Let's investigate this fundamental force to see just how it works. It's not just a necessary force, it's a fun force too. Magnetism is so cool. Interesting. Without magnetism, your cell phone would not work. That's crazy. All right. Feel the force. There's a title. Well, let's read the caption first, and then we'll do what Ms. Jones tells us to do with titles. Turns out you're not supposed to just put the word title at the top. Teachers are going to love this book. It teaches them both science and English. This author is funny. All right, feel the force. Ms. Jones says titles I have to think about and ask myself a question. Feel the force. Force, if I think about the definition from earlier, what is force? Force was the use of such power or energy or strength. So force is using power, energy, or strength. Feeling the force, feeling my power, feeling the energy, feeling the strength. Something that has to do with feeling strength. All right. When you put two magnets near each other, you can feel a push or a pull. The movement you feel is caused by a magnetic field. A magnetic field is an invisible area around an object, just like the video Ms. Jones just showed us. It's invisible. This field exerts a magnetic force that attracts or repels other objects. Magnetic fields look like curved lines around an object. Metal objects are most sensitive to magnetic fields. Any metal object that comes into a magnetic field will be attracted or repelled by the magnet. Here's another comic in our graphic novel. Look at this magnetic field. And the other person says, that is not the kind of field they're talking about. So they kind of put metals or magnets over a cornfield. Interesting. Corny. All right. Here is another text feature. Ms. Jones always says that pictures help readers really understand what they're saying. So let's look at the caption. The blue lines do not stand for football plays. They stand for Earth's magnetic field. So these are the magnetic fields that are even circling around Earth. Interesting. Magnetic fields are everywhere. In fact, even Earth acts like a very strong magnet. Deep in Earth's core, magnetism is created. The inner core is made of solid iron. The outer core is made of liquid iron or nickel. As the liquid iron moves around the solid iron, it creates an electric current. This electric current causes a magnetic field to form around the planet. So Earth is one giant magnet. Interesting. I see another bolded word. Ms. Jones said that they are aware, most likely at the bottom of the text. So let's see what that word means. Current, the flow of electrons. All right, let me read the sentence again, knowing the definition. As the liquid iron moves around the solid iron, it creates an electric current. It creates a flow. Okay, because it says current is a flow of electrons. And then that's what causes the magnetic field to form around the planet Earth. Try putting that on your fridge. Can't put Earth on your fridge. All right, our last page in our text, polar opposites. Well, first of all, the main question for today, I believe Miss Jones said, had to do with South Poles. I need to be paying attention because if that's my text focused question, it might be answered right here. Polar opposites. Just to be clear, this section has nothing to do with polar bears. It sure doesn't. Every magnet has two parts, a north pole and a south pole. These poles are at opposite ends of a magnet. It's these opposite parts that determine if the magnets attract or repel, right? Attract, I like you. Ooh, repel, ooh, get away, get away, get away, right? Magnetism rule book. Rule number 1, opposite poles always attract. Rule number 2, like poles always repel. Like poles always repel. So if it's north and south, is that opposite or the same? Ask yourself. Is it opposite or the same? Is the north of the magnet and the south of the magnet, is it opposite or the same? Oh, they're opposite. Okay, so it says rule book, opposites always attract. So if I have two magnets, every magnet has a north and a south pole, but it says the opposite ones attract. So if I have a magnet, let's say this is remote control. Let's say this is the north pole and this is the south pole of my magnet. You can't even see it. And then let's say I have another magnet. My Amazon Fire Stick. All right, what did I say? This is north and this is south. All right, so this is north. So this one, let's say, is north and south. If these are both norths, oh snap, they won't go together. Why? Because they're like poles. They always repel. They don't want to be together. Okay? But let's say I turned it around. Experiment gone wrong. Let's say I turn around. Now I have the south pole and the north pole. Woo! There's a force. They attract to each other. Interesting. All right. Just like you, magnetism always follows the rules. You do follow the rules, don't you? Hello? Depends on who's watching this. Bring the north pole of a magnet toward the south pole of another magnet. The two will pull together almost immediately. But if you bring their north poles together, they push apart. Okay, if it's north and north, similar to what I just said, they don't like each other. Okay, this crazy push and pull is the magnetic force. So this idea of push and pull, attract, repel, push, pull, attract, repel, that's what this magnetic force is. That's what's happening in this invisible field around us. Okay, that's what creates the ability for our remotes, the batteries in our remotes to work, right? You ever realize if you put two batteries in the wrong way, the remote doesn't work? It's because it's probably not the north and the south being put in correctly. You got to make sure that they're in correctly. All right. That was some good sex hunties. Okay, now back to our agenda for the day. So we close read the text, The Attractive Truth About Magnetism. And now in your second video, I would like for you to answer the text focus question with complete sentences using evidence from the text. So digest all that we just read. Think about how do magnetic forces flow through magnetic fields. Think about if one south magnetic pole and another south magnetic pole are presented, will they ever be attracted to one another? We answered that just now. But these are the two focus questions that you should have been able to answer by one, looking through the first observation of that first magnet, right? I'll pull it up so you can remember, jog your brain. Oops. Not that one. Right? Thinking about that. Secondly, with the video that the young lady showed us about the force, this invisible force that is around us that we can't see. And thirdly, reading The Attractive Truth About Magnetism. All right, so think about all those videos and text and pictures, and think about these questions that you're going to be answering, because in our next video, you will take your second piece of paper And you will be writing out these questions and answering them. Alrighty. I am looking forward to seeing your first exit ticket from this video, which would be all the questions that had to do with that first picture. Right? Those 4 questions on a piece of paper, writing them out. I already helped you restate them. Answer the questions fully and shoot me a text with that picture. Alrighty, I will see you guys shortly for video number 2 for our writing response for this text.